Dear viewers, you are welcome again. So in this video, we are going to consider difference and symmetric difference. And then let me first of all ask you a question. When you hear something like 9 minus 4, we all know that the answer is 5. So where is that 5 coming from? The 5 is coming from the first one, which is 9. So after you take 4 away from 9, what remains is what is 5. That 5 we are referring to as our answer is a 9. So the same thing applicable to a difference of b, or we use a minus b. You know, they're actually talking about a set, another set that is in A, but not in B. But there is something we've not mentioned here, that the intersection of A and B, they are not also part of X. So I don't know, maybe we can update this definition with that fact that A intersection B is not also in A. So in other words, we can actually say that a difference of B is a set of X in such a way that X is in A, X is not in B, and then A intersection of B is not also in X. First, to understand this particular concept, let's use another definition of set. Let's use another set A and another set B. That's very important. So let's say we have set A to be 1, 2, 3, and 4, okay? And we have another set B, which is 3, 4, 5, 6, and then 7. That's okay. Let's use this one. Let's use this one. So what we are going to do now is this. A minus B is now equals to 1, 2, 3, 4, then minus 3, 4, 5, 6, and 7. So what is the first thing we need to do is that we need to take away the intersection of A and B, and here the intersection is actually 3 and 4. So when we take it away, we now realize that A minus B has 1 and 2 in the first, while 5, 6, 7 in the next. What do I mean by that? Just like I've explained the other time, that 9 minus 4 is equals to 5. That 5 is inside 9 in the first. So the difference here is actually 1 and 2. It's actually 1 and 2. But that's not all. We can still also go further to find out what is the difference between B and A. So in this case now, the set of B will come first, minus the set of A. So that will give us 3, 4, 5, 6, 7, then minus 1, 2, 3, 4. So what about the intersection? The intersection is what is 3 and 4. It must not be in the difference. So what remains in the first set, B, in the first set, which is B, is now what? 5, 6, and 7, which is the difference we are talking about. So that is the Venn diagram. So the last thing we are going to consider now is called a symmetric difference. So they actually use the symbol of plus with circle, or you can say that a plus inside a circle sign. So we use this to represent symmetric difference. But it actually has two meanings which are equal. So the first one is that asymmetric difference B is something as A union B, then difference from A intersection B. At the same time, this expression here is still the same thing as A difference of B, then union B difference of A. Now we are going to solve one problem, that will help us to understand symmetric difference. So let's use the same set problem that we use for difference. So here we have A to be 1, 2, 3, 4, and we have our B to be 3, 4, 5, 6, 7. So as you can see them in circle there, but you can see clearly that they have something in common, and that is 3 and 4. So we are free. We can use any of the two definitions, but let's use the second one as you can have it in your lecture notes. So asymmetric difference of B is what? A difference of B union B difference of A. So from here, what is our A difference of B? Remember, 9 minus 4 is equal to 5, and that 5 is in 9, the first one. Okay, so what is A difference of B? You can see that when we take away what they have in common, what is common between A and B, when we take it away, then we take the remaining inside the first set, which is A, and that is what 1 and 2, because by the time we remove the difference, which is 3 and 4, what will remain is 1 and 2. So what about B difference of A. So we take away what they have in common, which is 3 and 4, and what is remain in B is what? 5, 6, and 7. So A symmetric difference of B is the union of A difference of B and B difference of A. That is what we have there. So if we are to come up with a Venn diagram now, we have to shade the part that has to do with 1, 2, 5, 6, and 7. And how can we come up with that? 1 and 2, we can see it on the screen. Okay, then 5, 6, 7, that is element in B when the difference has been deleted. Okay, so that's the Venn diagram on the screen is actually the graphical illustration of A symmetric difference of B. So let's proceed now to use this to solve some problems.